All right, welcome to the review video for Standard 5, Solving Systems Using Substitution and Elimination. So now we're going to look at a new method, right? We just started learning this in class. And this method is elimination. Now, it's a little bit weird at first when you are just learning it, but it's actually very helpful and ideally makes your life easier. So when you're working on this process and you're feeling like, I don't know, remember, the goal is that you can solve systems in a lot of different ways, so you can pick the easiest one and the one that makes the most sense based on the system you're given. So our system is 2x plus 4y equals negative 16. And then negative 2x plus 2y equals negative 2. I could isolate one of the variables in one of the equations and use substitution. I could also isolate y in both cases, in both equations, and set the rest of them, those expressions, equal to each other and use the equal values method. I could graph these and see where the lines intersect. But this is actually a system that is prime for elimination because when I look at my equations, I notice that the coefficients on my x's are opposites. So in math, an opposite of a number is what will add to that number to make 0. So the opposite of 2 is negative 2. And the opposite of negative 2 is positive 2. So instead of isolating anything, I am going to add these equations together just as they are. I'm going to write a big plus sign so I remember I'm adding them. Then I'm going to draw a big line underneath. Again, looks like a kind of strange version of the addition we learned many years ago. Then we just add the like terms together. So 2x plus negative 2x, those cancel each other out. They're opposites. So x's are eliminated. Then we have 4y plus 2y, so we end up with 6y total. The equal sign stays in the same place. And then we add our constant. So negative 16 plus negative 2 is negative 18. This is really handy because now I'm just left with a single step equation to solve for y. So as usual, we're going to divide by the coefficient on y, which is 6. We do that to both sides. Our equation has to stay balanced. And we get y is equal to negative 3. Then we want to find our x. We can use either equation. I'm going to pick the first one, just because. I'll check it with my other equation. So I'll say 2x plus 4 times negative 3, because now I'm replacing this y with the value that I found for y. And that should all equal, oopsies, that should all equal negative 16. So 2x plus 4 times negative 3 is negative 12. So I'm actually going to change this to a minus sign. So 2x minus 12 is equal to negative 16. I'll isolate my term with x, which is this 2x, by adding 12 to both sides of my equation. The opposites eliminate each other, and I get 2x equals negative 4. Lastly, I'll divide by the coefficient on x to isolate it. In this case, the coefficient is 2, so I divide both sides by 2, and I get x is equal to negative 2. So now we're pretty sure that our solution to this system is negative 2, negative 3, right? X, then y. to check this, I'm going to plug both of those values in for x and y into the equation that I haven't used yet. I've used it, but I didn't use it here. So that should say -2 times -2, because this -2 is a coefficient, and then we think x is -2 in our solution. So remember, -2 is happening twice, but from different places, plus 2 times -3. That's what we found for y. And that should all equal -2. So -2 times -2 is +4. 2 times -3 is -6. So we'll make that a 4 minus 6 equals -2. And then 4 minus 6 is indeed -2. So it checks out. Our solution is good to go. So with elimination, we're really looking for these opposite coefficients on the same variable. But sometimes we don't have that given to us right from the beginning, right? That first equation was pretty nice because we already had opposite coefficients. But in this equation, -5x minus 2y equals -1. -6x plus 4y equals -46. I don't see any opposite coefficients. -5 and -6, well, they're not opposites. It's not the same absolute value with different signs. The -2y and the +4y, those aren't opposites either. However, if we look carefully, -2 could probably become -4 pretty easily. So then that would be the opposite of the coefficient here on 4y in the other equation. So let's do that. Let's adjust our first equation by doing the same thing on both sides of the equal sign, right? As long as we keep it balanced, we can rewrite our equations. So to get from -2 to -4, I would need to multiply this by 2. I need to double it. But I can't just multiply that term by 2. I have to multiply every term by 2. So I'm going to write it out. Times 2, times 2, times 2. Now, you may see in other places, people put parentheses around the whole equation and just write times 2 once. That's fine. Same thing is happening. However, be very careful that you don't forget to multiply your constant by that value as well. That's a really common error. So I recommend actually writing it out next to every single term so you don't forget. Then I actually want to rewrite my whole system just so that I can make sure I keep everything straight. I know what's supposed to be where, what equals what, etc. It can be really easy to get lost if you try and crunch too much work together. So when I rewrite my first equation after multiplying every term by 2, I get -10x because -5x times 2 is -10x. Then I'll have minus 4y because -2y times 2 is -4y. And that's all going to be equal to -2 because -1 times 2 is -2. My second equation, I'm just going to rewrite it exactly as it was. -6x plus 4y is equal to -46. Cool. Now I can see opposite coefficients on the same variable. We've got +4 in the second equation and -4y in the first equation. So we are ready to eliminate. I'm going to add the equations together. Reminder that I'm adding. Then I just go down the line like I did in the previous question. So -10x plus -6x is -16x. negative 4y plus 4y, those are opposites. They're going to cancel each other out. The y's are eliminated. And then our equal sign stays in the same place. Negative 2 plus negative 46 is negative 48. To isolate x, I'm going to divide by its coefficient. That's negative 16. I'm going to divide by that on both sides. So I get x is equal to positive 3. Negative 48 divided by negative 16 is positive 3. Cool. Now, as usual with our systems, once we've found one value, we're going to plug it into one of our equations to find the other value. I'm just going to use the first equation, and let's go. So, let's see. So negative 5 times 3, right? Because this said negative 5x, and now I'm replacing the x with the 3. I'm substituting in that 3. Minus 2y is equal to negative 1. Negative 5 times 3 is negative 15. Minus 2y equals negative 1, right? That all stays the same. Then I'm going to add 15 to both sides because I want to isolate my term that has the y's. But be very careful in this case because this says minus 2y. When we take this next step, that's going to remain a negative 2y. That minus sign, that negative sign, doesn't disappear at this step. So be careful with that. So we get negative 2y is equal to 14 because negative 1 plus 15 is 14. To isolate y, we'll divide by its coefficient, which is negative 2. And we get y is equal to negative 7. Okay, so now we're pretty sure our solution is at 3, negative 7, right? X then y. But to check it, I'm going to plug those values in to this equation just to make sure I get a true statement. So we'll say negative 6 times 3, because our x was 3, plus 4 times negative 7, because our y was negative 7, is equal to, I'm going to move that out of the way, is equal to negative 46. Okay. Negative 6 times 3 is negative 18. 4 times negative 7 is negative 28. So I'm going to write this as minus 28. And that should all equal negative 46. Well, negative 18 minus 28 is indeed negative 46. So we have a true statement, and our solution to this system is correct. So with this elimination method, again, take a moment, think about what you need to work on. And remember, the key to elimination is these opposite coefficients. I hope that was helpful. Happy studying, and I will see you soon.